Greetings to everyone. This is Hari Prasad, currently working as Assistant Professor in the Department of Electrical and Electronics Engineering at Kamaraj College of Engineering and Technology. Now, we will have a discussion about the fundamental concepts of transformers. So, what is a transformer? A transformer is a static electrical device that converts the electrical energy from one circuit to the another. So, we will have a circuit here. So, by this I can explain you the concept of how it works. And before entering into the concept, we will understand like what is the basic fundamental principle that guides the working of transformer. So, the working principle is Faraday's law of electromagnetic induction. So, Faraday's law of electromagnetic induction, which indicates that it works on the principle of induction. So, induction, I have got a circuit. So, what will happen is, if I am applying the energy here, it gets transferred to the other part. So, here it is in terms of inducing, induction in terms of inducing. So, I am going to apply the electrical supply at only one particular part, which gets transferred to the other part. So, here we actually call it as inducing. So, it is in the similar fashion of mutual inductance. Okay. Now, this is a rough circuit of a transformer. We are connecting the transformer to the input voltage supply, we will mention as V supply. The first initial part is called as the primary, and the other side is called as the secondary part. So, which means the windings present at the primary side are called as primary windings, and the windings present in the secondary side are called as secondary windings, and they are mentioned as N1 and N2. The voltage applied at the primary side is called as primary voltage V suffix P, and the voltage that will be referred from the secondary side will be called as secondary voltage denoted by V suffix S. And when you are supplying the voltage here, what happens is the current flows through the core. Okay, current flows through the core. It reaches the winding part. It gets developed into a magnetic field. Flux is getting generated. Flux lines are generated, and they transfer the energy from one side to the other side, which means that the flux is flowing through the core. The entire core, and the energy is transferred from the primary side to the secondary side. So, based on the construction, the main part is core and windings. So, core, it is going to be made up of stampings. It is not a single solid core, whereas you have got n number of stampings which are combined together to form a core, single core. So, imagine like a notebook which is made up of n number of pages which is clubbed together to form a single notebook. So, it is there in that format. Now, we will move to the types. So, I am transferring energy from one part to the other part. Based on the application, I can classify into step up transformer and step down transformer, but actually there is no distinguish between a transformer as step up and step down. We call only transformers as ideal transformer as a case, and apart from that, any transformer that you purchase from the market can be utilized both as a step up and a step down. Here, step up transformer is used for stepping up the voltage. It is helpful in stepping up the voltage. Stepping down the voltage happens in step down transformer. How? So, the windings present in the primary side is going to be less when compared to the windings present in the secondary side. So, in this case, what happens is the voltage gets stepped up. Okay. So, the windings present is going to be more. There are more number of windings when compared to this side. So, your voltage is getting stepped up. The other side, when you are looking into the step down transformer, primary windings will be more and the secondary windings will be less when compared with the primary windings. So, in this case, your voltage will get dropped down. For example, if this is 11 kVA, now this can be 230 volt. It gets stepped down. Okay. Here, if it is like 230 volt and it comes to 11 kVA. So this is stepping up of the voltage. Now where do we find this? Is step up transformers, they find a major role in the generation part. So mainly in power plant areas. So the power has to be stepped up. For step down areas, it is mainly for local distribution. So that is generation part, and this is distribution part. So mainly for residential and industrial purposes. Okay, so you will be able to understand the difference now, what is step up transformer and step down transformer. But basically it is only a single transformer. I can connect based on the direction. Okay, if this direction is going to indicate step up mode, the opposite direction will indicate the step down mode. So there is no practical step up and step down transformer. It is only a transformer which can be connected based on their need. So the classification takes place only on that. Okay. Now we will discuss why transformer is actually rated in kVA and it is not in kW. Why? So this is an important concept where we will discuss in transformers why the rating is done in kVA. Now when I take transformer, I have got a core. So this is a core and I have got windings. Now when I supply current, when I supply the input here, what happens is this core is made up of iron. This is an iron piece or iron stampings or stampings. Now what happens is this core is responsible for core loss because of the flow of current. Now core loss, it depends on the input voltage. It depends on voltage. Whereas all these windings, copper windings, where all these copper windings, they also generate heat when current flows through it. So it depends on current. Copper windings depends on current because of the flow of flux inside. Okay. So core loss, it is depending on voltage. Copper loss, it is depending on current. But these two are major responsible factors, and power factor is not at all considered. We depend only on voltage and current and we do not focus on the power factor. So from voltage I am taking as kilovolt and from current I am taking the unit as ampere. So it is totally called as kilovolt ampere and we do not depend on the power factor. So this is not at all considered. So that we will not go into kilowatt. Okay, so this is mainly the reason that why we are focusing on kVA instead of kilowatt. Okay. Now apart from that, there is another type of classification actually. It is called as core type transformer and shell type transformer. So now what is core type transformer, what is shell type transformer? We have to understand the concept. Now transformer, as I have mentioned, it is not made up of a single piece. It is not going to be made up of a single piece like this, whereas you have got n number of stampings which will be clubbed together to form this core. When all these are combined, you get the resultant here. Okay. So core type, in a sense, we have got I core and E core. I core and E core. So stamping is going to be in the shape of I, or it will be like this. Okay, I core. Another is E core. So you have core stamping manufactured in the shape of E. Okay. Now there is also called as L core. So stampings are manufactured in form of L. Okay. Now I can utilize any of these core models and I can form transformer shapes. So core type is the common model that we use in all the circuits. Okay. So this is core type transformer. It is like square in shape. So this is formed by L core. If you combine two L, you will get a core. Okay. Now what is shell type? Shell type, you have a E core and this is closed with I core, whereas the primary and secondary winding is only present in the center part of E. So this is primary winding, this is secondary winding. So the windings are enclosed inside. The windings are enclosed inside, and here the windings are exposed. Okay. So, primary and secondary are present at both the ends. Here it is enclosed inside the single limb. So, we call this as limb. Okay. So, this is based on the construction methodology. Okay. I hope you are given a basic output or outline of how a transformer works, and the further concepts we will discuss in the next upcoming video. Thank you all.